Hey, Lou again. Today we're going to look at something called a Voltaic Pile, which is kind of a battery that was created by Alessandro Volta in 1799. It's made of alternating two different metals, in this case aluminum and copper, which is a penny. This aluminum is just a little charm. In between this is a felt piece of rag soaked in vinegar. That acts as the electrolyte that conducts electricity between the two, and the copper and aluminum act as electrodes. These are then stacked one on top of the other, as you can see here, and the net result is you end up with a device that produces voltage. That device, the more of these that I stack on there, the higher the voltage will get, but that was about as high as I could get it without them falling over. If you look at the voltage meter, when I connect the output leads, you can see that we've got a little over 1.2, 1.3 volts. So actually a pretty decent little battery. Now this battery isn't strong enough. Later on we're going to connect a few in series and power this little LED light. But this battery isn't strong enough for that. I'll need a little bit more than 2 volts. So in order to do that, what we're going to do is connect another type of battery. This one uses lemon juice as the electrolyte, galvanized nails, which are coated in zinc, and copper wire. So the copper becomes my positive electrode and the zinc becomes my negative. So let's connect those up and see how much voltage we're getting out of our lemon battery. And the lemon juice is acting as our electrolyte. So here, I'll connect this. Is our negative. And then when I press this onto the positive, we get almost a volt, 0.95. So that's not too bad. Now I was experimenting to see if it made any difference to have more surface area in zinc and more surface area in copper. So I made a version here with just a single nail. So let's see how that works. Put this up to the negative. This up to the positive. About the same, not really much of a difference, to be honest. So in this particular case, having more or less didn't make too much of a difference. Now I'm going to connect these in series and see if we can power that little LED. So this is my negative. I'm going to connect that to the positive. And then I'm going to connect the positive of this lemon to the negative of this lemon. And then this will be our positive on this side. So let's see if we can actually end up powering our little LED light. So this is our negative. Positive. Sorry I don't have the proper color leads, but you can see in there that the LED is lit. Not very bright because there's not a lot of current, but there is enough voltage to light an LED. So you can actually create a battery out of this. Now the more surface area you have, in theory, the more output you'll get. So if I were to keep combining copper and aluminum discs, this would keep producing more and more voltage. I had a practical limit here. I couldn't stack it any higher and keep it from falling over, so I'll have to create a different version of it. But the aluminum is the only challenge here, and I ended up getting little charms from Amazon. So they're actually got a hole cut in them so you can hang a charm and engrave them. But it's just a little aluminum disc, and this is any penny. All of the American pennies are clad in copper. Anyone made before 1982 is all copper, and those will work fine as one of the parts of the battery. I'll put a link on where you can buy these. Now you can also use just aluminum foil, which actually is kind of a pain. So I went ahead and bought these. They weren't too expensive. I think I got 50 of them for about $7 or $8. So that's the only thing I really had to buy. This is just regular felt that you can get in any craft shop, and then vinegar that you can buy at the grocery store. You don't have to create a fancy contraption like this to hold it. You can lay them down sideways and stack them that way, and with some cardboard holding them vertically. But it works pretty well, and a little bit of history about how batteries are created. Thanks, everybody. See you later.